Okay, so we've talked about some algebra and geometry. One thing we haven't talked about at all yet is statistics. So I wanted to make sure to get some of that in at least, and we'll still keep going back and forth between all of the different topics, algebra, geometry, and statistics. Today is going to be statistics only. So a lot of the statistics problems are about graphs or about how to sample things, how to collect data, or about finding mean, median, and mode. So I wanted to go through all the different types of graphs we can use first. So one of the main type of graphs is called a line graph. This is best for data over time. So on this graph, I did days and temperature. So like day 1, the temperature would be 56 degrees, or day 2, it looks to be about 58 degrees. So you can find information from the graph, but a lot of the time they just give you some information and say which type of graph is best. So if they gave you maybe your height and your age, as you grow up, you get taller, that kind of data would be best with a line graph. You can also have a double line graph if we had a second set of information that was also graphed on here and connected with lines. Maybe you want to compare the temperature in 2 cities. Each city would get its own line graph, and so 2 of them on the same graph is just called a double line graph, but it's still best for data over time. So next would be a circle graph, which is also called a pie chart. And this is best when you want to compare parts of a whole. And often you use percentages with them. You don't have to. This one's not currently percentages, but we could find the percentages for this pie chart. So I did favorite colors, and so each of these, since there's no percent symbol on them, that's, say we surveyed a group of people and we found 18 like the color green, 27 like pink, 13 black, 24 red, and 45 blue. So that is not the percentages. Percentages would have to add up to 100%, or they have to have the percent symbol on it. To find the percentages, we would need the total amount. How can we find the total of all the people we surveyed? Add them all together. Total amount is just all the numbers added up. Which will give us 127 people. So 127 people were surveyed. To find each percentage, we have to do some division. So let's say we want to find the percent who like green. We're going to take the number of people who like green, so that's the part. Part of our data was the people who like green over the total amount of people. So we have 18 over 127. Let me bring a calculator up. And we'll divide it out. So we can do 18 divided by the 127 is 0.141, big long decimal. To change this to a percentage, what do I do to this decimal to now show what it would be as a percent? Multiply, okay. Multiply by what specifically? Multiply is right. But what are we going to multiply by? What are all percents out of? What's the biggest percent you can have? 100. If we times this by 100, that will change it to the percentage format. We've seen a lot of the time where we have a percent, you know, we'll start with like 25%, and I've told you take 25 divided by 100, and that'll change it to its decimal. And we're going to use it, we have to have the decimal format. When we want the percentage, we just do that backwards. So this would be 14%. We're going to round to the nearest whole number. So 14.1, if we're going to round at the 4, we look at the next number. Since this is between 0 and 4, this 1 is between 0 and 4, we keep the 4 the same. So this would be 14%. If they had said the nearest tenth, let me bring our decimal back up, 14.17. I'll write this to the side. 14.17, if we round to the nearest tenth, the number next to the 1 is between 5 and 9. So that would round up. We don't keep it the same. This would be 14.2%. Both could be correct answers depending on what they ask. If they said find it to the nearest whole number, 14%. Find it to the nearest tenth, then 14.2%. Next is a bar graph, and this is best to compare categories. So our pie chart could also have made a good bar graph. It depends on what you're trying to do. The pie chart, that information, the favorite colors, if we want to see how do all those compare to each other, the pie chart is better. If we just want to see which one's the most, then the bar chart is better. Best to compare categories. So, you know, usually it's groups or it's numbers or it's topics. This one I said your favorite movie. So some liked drama, some liked sci-fi, romance, action, or comedy. Sometimes with the bar charts, you might have to, they like to put these in context of another question. Like maybe they ask you to find the mean on this bar chart. So if they ask you to find the average, which we're going to talk about later, how to actually find the average, but if they ask you to do that, you have to be able to kind of estimate. We look over to the side and we say, well, how high up is that bar? So what do you think this bar is at if we go over to the side? And if you can't read these numbers, they're kind of small. I'm going to rewrite these numbers out. So where do you think, okay, 48, that's a good guess. Might also be 47. When you're estimating, a couple answers might be right. Some people might see it and think, well, this looks like 46. Some might think 47. It's okay to estimate on these bar charts. They will have the answers written in such a way that if you're estimating pretty close to what they originally intended, that you'll still get the correct answer. Next is a histogram. So a histogram is also a type of bar chart. The difference between a bar chart and a histogram is you have continuous categories. So what we mean by continuous categories is they're all connected. So on this histogram, age is our bottom number. This bar is representing any age between 20 and 30. and the next one 30 to 40. So they're categories that just keep going up. They're all connected, whereas our last one, when it was the movies, you couldn't connect romance to sci-fi to drama. They all just had their own category. Between 30 and 40. But they can ask you the same types of questions. They could ask you to find the mean. They could ask you just to read it and, you know, how many people are between the age of 50 and 60. Well, that would be 5. So it's read like a bar chart. It's just only good for continuous categories. A stem and leaf plot looks really weird. A stem and leaf plot is also good for continuous categories, but instead of wanting the visual picture, you just want to organize the data in a chart. So how do we even read a stem and leaf plot? The stem and leaf plot, the stem is the first number. It's usually the tens digit, maybe the hundreds, depending on, again, what they have written over here. The leaf is the second digit of the number. So this 2 is the start of a number with the 3. That number would be 23. But then you can use the 2 again and put it with the 7. That would make this a 27. So how about on the next row? What's the next number of our data? Good, 31. So instead of writing out this big long list, they just have it organized so it's a little more compact, especially when you have a lot of numbers like this. When you write them all out, it gets confusing. So the stem and leaf plot is just a way to organize it. I actually used that histogram. So the histogram, there were 2 people between 20 and 30. I'll go back a page to show you. Between 20 and 30, there were 2 people. So for actual data, that can be any numbers between 20 and 30. We have 2 people between the age of 20 and 30. They can change it up a little bit. Sometimes they'll put some information down at the bottom. They'll say something like 2/3 means 2.3. So instead of 2, 3 combining together to be 23, if they write that extra information at the bottom, that means we're doing the decimal 2.3. All of these now become 2.7, 3.1, 3.2. But they have to tell you that information. If it's not stated explicitly, then you just assume 23, 27, so on. So when they actually ask a question, oh, I thought I included one. I'm going to have to make up a question really quick. I apologize. I thought I included one in. John records his height each year. What kind of data graph would be best to represent the data? It'll say something like this, and then it'll give you options. So it will just give you a situation, and that's why I kept giving you the information about, well, this is best for this kind of situation. So given this situation, which of these is the best type of representation?
Line graph.
Good. Line graph is correct. Since it's over time, each year, then we use the line graph. So any other questions about the data graphs before we move on to mean, median, mode, and range, which are also called measures of central tendency? Okay. So I think we're ready to move forward. Most of those, it's not a whole lot of math to do. It's just basically having memorized what's the best type of graph for each situation. So measures of central tendency, you have probably seen before. You usually start doing these in elementary, but we keep seeing them over and over again. So mean is the fancy word for finding the average. So to find the average, again, you'll be given a whole bunch of data. Statistics is you've collected a bunch of information. Now we want to analyze this information and find more about it. So to find the mean, you add all the data you have together. And divide by however much data you have. So let's give just a little set of data. I'm not going to include too many numbers. And they're not necessarily going to give you the information in any particular order. So for this set of data, then we need to add all the numbers together and divide by how many there are to find the mean. If we add them all together, that's going to give us, and definitely use a calculator here. Adding these together by hand can just take too long. The calculators are super useful. 86. So then we said divide by how many numbers there are. What are we going to divide by? Good, 4. We literally just count how many numbers there are. 1, 2, 3, 4. We're going to divide by 4. And again, use a calculator. I don't know what this is divided. Gives us 21.5. So that's how we find the mean. The median is the middle number. So to find the middle number, you must put the numbers in order. So for our little example here, if we put them in order, and we want to put them in order from least to greatest, I should include that, least to greatest. If we put them in order, that's 16, 20, 23, 27. So when we have 4 numbers or any even amount of numbers, there's no one middle number. If we cancel out the first and the last, there's 2 numbers here in the middle. So when that happens, we actually have to find the average of those 2 numbers. We would have to add 20 plus 23 and divide it by 2 since there's 2 of them. And 43 divided by 2 is 21.5. This one happens to be the same as the mean. That does not always happen. That was just random. I picked random numbers, so it can happen, but it doesn't have to. If we added in a fifth number, then when we put them in order, there's definitely a middle number. So with 5 numbers, we don't have to find the average. We can just look at it and find the middle. So what's the middle number of this set of data? Good, 23. If there's a lot of data, it's easy to see when there's only 5. If there's a lot, I cancel out first and last, and then second, second to last, and just keep going, doing one at the beginning, one at the end, until I isolate where the middle number is. Mode is the number that occurs most often. I remember mode because it starts with the same 2 letters as most. Okay. And sometimes there is no mode. Let's go back to our original set, since that's all the examples we have for the rest. If there is no repeated number, none of the numbers repeat, then we have no mode. If we have 2 sets of numbers, so let's add a 20 here at the end. So right now, the mode is 20 because 20 occurs twice and all the other numbers only happen once. But if we add in one more number, like 16, now the mode is 20 and also 16. So mode is kind of flexible. You can have no mode, you could have 1 number as a mode, you could have 2 numbers, just depends on the data. So then the last is not a measure of central tendency, but it's still used a lot, so I included it. And it's called the range or the spread. And it's just the highest number minus the lowest. You want to find out how far apart is everything. So for our data, the highest is 27 and the lowest is 16. And we just subtract those 2 numbers. $11. So that means all our numbers are within a range of 11. So it can be a little more difficult when we have more numbers. And let me add in a question here. Which measure of central tendency is best for the data set? Okay. So finding mean, median, and mode, that's the same as we just practiced. Knowing which one is best is some new information. So median is best median is best when you have outliers. So here's another word we need to know the meaning of. So an outlier is a piece of data that just doesn't fit. All of them seem to be around the same amount, and then outlier is just going to be far away from all the rest of the numbers. So what's our outlier for this data set? Which number just doesn't look like it fits in? Good, 52. Most of the data is in the teens and the 20s, and then all of a sudden we get a 52 out of nowhere. So in this case, we wouldn't even need to find the mean, the median, the mode. We know that the median would be the best for this data. It has an outlier, median is best. And the rest of the data. So mean is best when there's not an outlier. And mode is pretty much never best. So it's only going to be between mean and median. Outliers. Okay. So let's practice. We want to find the mean. What do I do first to find the mean of this data? Add all the numbers. So when you have so much data, you have to be very careful typing it into your calculator. It's really easy to miss stuff. Sorry, and it takes a long time to write it all out because there's so many numbers. 15 plus 52. So sometimes what I do when I write it all out and I'm adding it together is I'll cross out numbers as I go. I'll say, okay, 16 plus, I've done the 16. So if you need some organization and you're worried about missing a number, cross it off as you go. Since my calculator keeps disappearing, I'm not going to continue to do that. 25 plus 18. Oh, and be careful. So luckily this one shows, notice I missed a plus sign in between the 23 and 21, which means I have to start again. 16 plus 25 plus 14 plus 23 plus 21 plus 25. 18 plus 13 plus 12 plus 17 plus 15 plus 52. 251. So now we've added them all together. What is our next step?
Divide by 12.
Divide by 12. There are 12 numbers. So we divide by 12. And it's 20.9, depending on where they ask you to round. Let's go to the nearest whole number. So should this stay 20 or should we round up to 21?
21.
Good. Up. It goes up to 21. Very good. So there's our mean. Our median, we have to put them in order. Again, I cross out as I go because it's hard to keep track. With so many numbers, you're just going to lose track. So median, we look for the lowest, which is 12. Next is 13, 14, 15, 16, 17, 18. And the good thing about putting it in order, it's easier to find the mode as well. You'll see if we get any repeats as we write it in order. 21, 23, and we do have some repeats, 2 25s, and then the 52. And if you write it out and you're not sure, did I miss anything? Count how many numbers you've written down. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know we got them all because there were 12 numbers. So we already know the mode since we saw the repetition. There's only one mode and it's 25. And now we're looking for the median. So I always do first, last, second, second to last, third, third to last, because I have no idea what the middle number is unless I track it this way. We do have two middle numbers again. What do I do with those two numbers to find the median? Add and divide by 2. We have to take the average if we end up with 2 of those middle numbers. And that will come out to be 17.5. If we round to the nearest whole number on the first one, they probably want the nearest whole number on this one. So what should 17.5 round to? Is it going to stay 17, round up to 18?
$18.
Good. This rounds up to 18. So we found mean, median, mode. And then just to include that last topic, even though it's not a measure of central tendency, it's used a lot in data, we want the range, which is the highest number minus the lowest. Again, finding the median helps us because we already know the highest and the lowest. Gives us 40. Good. So usually what I've seen so far from looking at those past OGTs, usually if they actually ask you to find the mean, the median, or something like that, it's going to be more than just finding only the mean or more than just finding only the median. Actually, I might skip, no. Okay, I'm going to skip to this one and then go back to the other one. So, Rashad and Eric were competing with each other to see who could raise the most money for charity. Sorry, spelled a couple things wrong. The amount they each collected each week is shown in the graph below. On average, how much more money did Rashad collect than Eric each week? So on average means to find the mean. But the question itself is actually asking you how much more money. This is what we need to find the answer for. So it's not just asking you what's the average, it's having you do some extra steps. So we want to start with Rashad, who is blue. Again, this is really tiny, but the blue is Rashad, red is Eric. So we need each of their averages individually. So from our blue bars, we need to find all the numbers. So Rashad made $80 the first week. Go up to week 2. The blue bar for week 2 is 120. For week 3, we go up and it's 140. And for week 4, it's 60. Okay. So find the average for this. What is the average for all those numbers? Instead of asking you each step, I'm going to give you a second to just do the whole thing. Find the average of all of those. I got one answer saying 73. My guess is maybe you either divided by the wrong number or you maybe missed a number when you typed it in. These ones, you just have to be so careful when you type everything in. We want to add everything together and divide by how many there are. So now I got a second answer of 100. 100 is the correct average. If we add all 4 together, we get 400. And since there were 4 weeks, 400 divided by 4 is $100. So just be careful. Usually when you get a wrong answer on these, it's a calculator issue. Maybe you missed a plus sign, maybe you missed a number. It's not usually that you don't know how to do it. It's just calculators can be tricky if you're not paying close attention to all the details. So now we go over to Eric. Eric's in red, so he has 140, 100, 100 again, and 40. So what is Eric's average? Good. I have a couple people say 95. So his average is 95. Again, add all 4 numbers together, divide by 4. So those 2 are the averages, and we want to know how much more. So when it wants to know how much more, what do we do with these 2 numbers to find how much more Rashad made on average than Eric?
Subtract.
Good. A couple people said subtraction. 100 minus the 95. So if this were one of those free response OGT questions, you do want it labeled. Labeled that you're doing Rashad's average and show the work. Eric, we would still need to show the work. We don't just want to write 95 without showing that we did. Sorry, I was doing Rashad's average again. Let's fix this. You would want to show the work for Eric. Equals 380 divided by 4. And then you would want to write a final sentence, always answering the question. So we know Rashad collected, $5 more than Eric. Always do that conclusion sentence and make sure it's answering the question that was asked. Okay, so we need to go back a page. I put these in a bad order. So this is also dealing with averages. One of just the classic average questions is to kind of make you do averages backwards. So this says Casey wants her overall grade, wants her overall grade in her math class to be an 80% or higher. This number is the average. I meant to underline. We already know the average. Her grade is based on her test scores, and her first 3 test scores are 70, 86%, 88%. So test 1 is 70%. Test 2 is 86%. And test 3, 88%. What is the minimum score Casey needs to make an overall grade of 80% in the course? So test 4 is what they're asking for. We do not know the 4th test. The 4th test is not the 80%. So normally when we do the average, we add, then we divide by the number of numbers we're working with. We're going to have to do that whole process backwards. Instead of adding, then dividing to get the average, we're starting with the average. And we have to go backwards. So what is the opposite of division? Oh, one person is already saying the answer, 81%. I don't remember. We're going to find out. Multiplication. So we're going to multiply by the numbers, by how many there are, or how much data. So how many data points do we have? Okay, so this is tricky. The fourth test that we don't know also counts as one of our data things. If we did know it, we'd be doing 70 plus 86 plus 88 plus that last test. So even though we want to say 3 because those are the numbers we know, we count the one we don't know as one of the pieces of data. So it's actually 4. Good. And that's just a common thing that happens all the time, which is why I asked how many there are. So we're going to do the average 80% times 4, because there are actually 4 tests we're looking for. 80 times 4 is 320. So then we still continue to go backwards. The last step will be the opposite of our addition. So what's the opposite of addition? Subtraction. So now we want to subtract all of the data numbers we do know. 320 minus 70 minus 86 minus 88. Minus 70 minus 86 minus 88 gives us 76%. So that would be the fourth test score we need to keep an overall grade of 80%. So with multiple choice tests, there's often a second way to do things, which is why I included this question twice. If you can't remember the process, you're like, I don't remember how to do all this backwards. Well, we can try our answer choices. Let's try answer choice A first. We have our 3 test scores, 70, 86, 88. And let's pretend the fourth one is this 70% for answer choice A. Now we just find the average like normal, which we're more used to working with. We'll still divide by 4. 70 plus 86 plus 88 plus 70 is 314. Divided by 4 is 78.5. We know we wanted an average of 80, so this does not work. So it's not answer choice A. So the only problem with doing the multiple choice is we don't know how many times we're going to have to try this, but it's a good strategy, and I've shown you in a lot of different ways. It's a good strategy to use your answers when you can, if you can't remember how to do it the regular way. So B, answer choice B, we're going to still have the same 3 beginning test scores, but we try 76 instead, and we find this average, which we know, since we've already solved it, we know this will be the correct average, but it's good to still show all of it. We get 320 divided by 4 is that 80%. So we got the correct average, and we know that answer choice B is our answer. So just a second way to solve that same type of question. Only works if it's multiple choice though. So another type of question you'll see with these statistic type questions is sampling methods. They're going to give you a situation and say, how should you collect this data? So for sampling methods, you want to make sure that your collection is random. You don't want to select I'm going to only survey my best friends. That's not random. You also want to make sure, sorry, I lost my train of thought. It cannot be voluntary. Voluntary surveys are not good. They're not accurate. Oh, and the last one is it covers the entire population you're surveying. So when we say population, it's not like the population of an entire city. Population. Let's say at my office, I wanted to know how many women had blue eyes. Well, I would only survey the women because the women at my office would be the population. So you just want to make sure you're addressing the right population for the situation. So let me give you, this is kind of all generic. Let's do an actual situation so it makes a little more sense. So they'll give you a situation. Mary wants to know the favorite game app of the students at her school. So there's the population, students at her school who own smartphones. Actually, that needs to be part of the population. That's more specific. The students at her school who own smartphones. So what sample should Mary use? And then they'll give you a couple of options. Notice they all say random, so all of them fit the random category. We want to make sure it's not voluntary and that it fits the population. So a random sample of the students in the computer club who own a smartphone. So this is good because it's the people who own a smartphone, but it's bad because it's too specific. We don't want just the computer club. We want all the students at her school. So answer choice B. Okay, so we have one person saying the answer is C. Let's go through and find out. So B is a random sample of the students who are waiting to take the bus who own a smartphone. Again, that's getting too specific. Even though that might have worked, it doesn't include all the people who maybe have parents driving them to school, or if it's high school, maybe they own their own car, or maybe they just walk. So it doesn't cover enough of the population. It sounds good, but it's not the best fit. Next one, a random sample of 2 students in each homeroom who own a smartphone. So we already had someone say this is the answer, and they are correct. Homeroom, it's assumed, they kind of assume a little bit of information, but homeroom, usually everyone in the entire school would have, if homerooms even exist at the school, everyone in the entire school would have to go to the homeroom at some point. So it gets the entire population, it's still random, and it's not voluntary. And then the last one, just to show why it's not the best fit, a random sample of the students in her English class. Again, that doesn't fit the entire population. So next example, a grocery store is thinking of rearranging their store layout and they want to know whether customers prefer the current layout or the new layout. On each receipt they print, they put a link to the survey and state that everyone who takes the survey has a chance to win $500. Explain why this survey does not provide a representative sample. Give an example of a method they could use to create a survey that better represents their customers. So why is this bad? And remember our 3 things. It needs to be random, needs to not be voluntary, needs to cover the population. So why is printing a survey and saying they could win $500, why is that bad? So not seeing any answers yet. I don't know if it's just taking a long time to type or not, but I'm going to start talking about it. So, okay, set out of, they don't have a set amount of customers. They're not talking about the layout. So the biggest reason why, so a set amount of customers is kind of close, but the biggest reason why is this is voluntary. They're not saying everyone who's given this receipt will take it. They're saying, hey, if you want to take it, putting a link to a survey, that means it's voluntary, which is not good. And then the store layout part, that's just part of the situation. It's not part of the population. They could have said anything about that. They could say a grocery store is thinking of adding a new aisle in. The biggest part we want to focus on is who is being surveyed. So this being voluntary is bad. We don't want a voluntary survey. Most people aren't going to do it. Most people won't do a voluntary survey, and we don't get a good idea of the people who actually take it. We don't know if it was the mom with 3 kids, or the single dad, or the teenage boy just buying a monster. You know, most people won't take it, and we don't know who has taken it. So a lot of the times when it's bad, it'll be bad because either they're surveying the wrong group or because it's voluntary and you don't want voluntary. So what could they do differently? We want it to be random. We don't want to isolate a group. Like if you said, let's survey only the women coming into the store, that doesn't give you a good population. We want all the customers. We want to hear from every type of person who's going to come shopping here. So it's best to pick a random number and say, I'm going to survey every 5th person, or every 4th person, or 10th person. Who comes into the store. Since we're trying to figure out for this specific store, we want to survey the people who are coming to shop at this store. So the every 5th is what makes this a random survey. You're just picking a random person. You don't know what type of person it will be. Maybe the 5th person is going to be that teenage boy, or maybe it's going to be a grandma. We don't know. That's why we pick it, because it makes it random. Okay, so one more. A company wants to know how many of their workers would like a cafeteria installed at the office. What sample should they use? So what do you guys think from our answer choices, A, B, C, or D? A random sample of all the managers, random sample of 5 workers from every department, random sample of female workers, that was supposed to say workers, a random sample of all the workers older than 45. So we have one person say B. Okay, good. All of you guys are saying B, and that's correct. All the others are too specific. Answer choice A says managers, we only want workers. Answer C is all the female workers, but we want everyone. And D is all the workers older than 45, but again, we want everyone and not that specific group. So that's all the material I have for today. Since we have a few minutes, I just want to encourage all of you to be practicing some questions. I think I've mentioned once you could try your public library. You can also just Google OGT math test, and then you can go to this Ohio Department of Education website. And they'll have some tests that they've released. These are 2004 through 2009 tests. You can either click on the PDF link and it will bring that up. So here's some practice questions from 2004. And then they've split it all over. Answer document isn't super useful. This is what it looks like for those free response questions and for the multiple choice. Like this is where you're going to actually put in your information and select your answers and write your answers in. So it'll give you an idea of what it looks like. But if you want to check your work, you want the answer key. The answer key is the answer to all the multiple choice questions. Again, they give a lot of information. You want the very last column. Question 1, the answer is A. This content standard benchmark can sometimes be confusing, but we only want the last one. And for those free response questions, if you practice them and you want to send me a copy of what you've practiced, I'm happy to take a look and say, well, I think you'd get this score. If you also want to check what the scoring guide says, the scoring guide, if it will come up, I think it's still loading. The scoring guide will give an example of how they're going to grade it and some example answers of what good responses are. Not sure if it's going to load. Sorry, I am not quite sure why this one's not loading. There we go. Okay, so it'll tell you what question, item 5, and then it'll tell you what they're looking for. So you'll get 2 points as if you find the volumes of both cans, and so it'll tell you, you know, this is what you're looking for and how you have to find it. Again, if you want to practice some of those free response ones and send them to me, you could email it or just text me a picture. I'll take a look and say, this would give 2 points or this would give 1 point. So any other questions before we end today? Well, thanks for joining me. The next time is Wednesday at 6:30. Well, unless there's any requests, I'll pick a topic again, but let me know. You can either send a chat message or a Remind 101, and you can tell me I'd like more algebra or geometry or statistics. So have a great day, everyone.